Today we are in a bit fast. So first thing is IV characteristic. Now this one which you just see here, first one, this is the IV characteristic of a simple wire, which actually tells us V is equal to IR at constant resistance. Now, if you remember that, I told you this line will be straight till there is a constant temperature. As soon as the temperature changes, this wire will be no longer straight, but definitely will be a curve, right?
Right.
So basically, whenever you see this kind of line, and if somebody will ask you what is that, what this line tells you, you can tell it that V is directly proportional to I at a constant temperature. And this particular graph shows a simple current carrying wire. All right. And if you want to find
Okay.
out the resistance of that wire, how will you find out? Simply take the gradient of this line. What is the gradient, by the way? Y2
It's
minus Y1 over
okay.
X2 minus X1, and you take a reverse of this and you will get the resistance of the wire. All right. Any question
All
in
right.
this? I want you to
No.
I want you to copy this.
Resistance equals to 1 over the gradient.
Yes. Zoha,
Why
yeah,
is
Zoha,
it equal to 1 over
just
gradient?
one quick thing. Uh, I want you to just talk to your academy. Yeah, this is related to between you and your academy. Just talk to them. All right. Hello.
Okay.
All right. Okay.
About
Okay. Let's move on further. Now the thing is, the second important thing. If you can see, this is a filament lamp. Now, can you see a small difference between the graph of a filament lamp and the graph of a wire? What is the difference?
graph of a filament lamp compared to a graph of a wire.
We have just seen a graph of a wire which shows that resistance was constant because it was a straight graph, right? But here, if you see that the graph is changing technically, the up, if you increase the voltage, the current will be increasing and it will be a curve, technically speaking. And if it will be a curve, we know that resistance is not constant.
Yeah.
Resistance resistance is not constant means temperature changes. So basically what happened, if you turn on the lamp, or you can say filament lamp, as you simple bulb I'm talking about, then what happened? The temperature of the what you call bulb or a lamp changes, and because of that, resistance will no more be constant, but it will be changing as well. All right. Now, important thing. You tell me if the voltage increases, the current increases, and how the current is increasing. I mean, will it be increasing or reducing?
Increasing.
But it tells you something else. If you remember that, if the gradient is like that, it means the gradient increasing. If the gradient is like that, it means gradient is reducing.
Oh.
Okay.
So the rate
It
is
actually, yeah,
decreasing.
yes, it means rate is decreasing. And we have a formula R is equal to 1 upon M, right? So it means 1 upon smaller value will give you R more value. So technically speaking, in the first half, in the positive half, R is increasing. And in the lower half, R is reducing. That's what our calculation is. We know that as the current increases, resistance also increases. Why? The reason is very simple. Because when the voltage increases, the resistance of the wire increases. The reason is the temperature increases. And as the temperature increases, more collisions happen. So resistance technically increases. That's what's written
Hmm.
here. If you read it, now you will understand that resistance is not constant. As current goes up, Vi increases and the resistance therefore gets bigger. This is because the filament are very narrow and so heat up appreciably as current increases. We can still apply V is equal to IR, but only at a given voltage and current. Now remember that we cannot find out the simple gradient, but we have to find out a gradient at a specific point like that. So that's the reason I'm saying rate of change increases or rate of change reduces. All right. So if you double our value of voltage, the current will increase by less than the double value. So here it will be not be same. Like for example, if I say voltage is 2, it will not like current will not increase at the same rate, but a bit less or a bit more depending upon. But one thing is for sure, resistance will increase in that. So here it will be no more a resistance constant concept. It means that here resistance is also increasing along with VI characteristics. All right.
Sir, if in the exam we were to describe the shape of the graph, do we just say that the as voltage increases, the current decreases, or
No, 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 no.
it
Current is
increases and then
see.
decreases?
First of all, they will ask you what is that shape, what is the particular equipment this is, or what is that component. So you have to say them this is a filament lamp. Now, how do you explain that? You will say that if you have to explain in a way that if you see this graph shows a curve on both the sides, in the positive and in the negative axis. So you can say that resistance is not constant in this graph, right? So if you see the positive half of Vi, this one, you can see that as the voltage increases, current increases. And if when the voltage and current both increases, if you see this curve, right, this rate is reducing. Technically
Okay.
interesting is it rate is reducing. But if you see the formula here, the formula says R is equal to 1 upon M. So rate is reducing means if M is reducing, what will be the value of R? Will that be increasing or reducing?
Increasing.
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 So if you really want to say that, you can say that if you increase the voltage, current increases and along with the current, resistance will also increase. And and what is the reason of resistance to be, I mean, resistance to increase? Very simple. Because the current increases, temperature rises. When temperature rises, the particle of the resistance heat up appreciably. So actually the collisions with themselves and collision with the current increases due to which actually resistance increases. So it is due to the temperature. Same thing if you see here at the back, you can see if the voltage reduces. So what they're saying is resistance reduces as well. All right. So this is what the thing is.
Okay.
Okay. Once you write it, then we will move on. If you write it and read it, is there any problem you will, if is there anything you do not understand in that, then let me know.
No, this is understandable.
Understandable? Good. Now let's talk about the diode, which is very interesting. That is the third kind of component here. Now, when you're talking about a diode, remember that diode is like this. This is your diode sign. And this is an sort of a switch you have it, all right? This is your anode and this is your cathode. Can somebody tell me what is meant by anode and what is meant by cathode?
Anode attracts positive electrons, cathode attracts negative electrons.
No, but on itself, what actually is anode? Which electrode anode is?
The negative.
No, anode
No,
is
the
positive.
positive.
Anode is positive. Cathode is negative.
I always get that mixed up.
No problem. Anode is positive and cathode is negative, right? Now, once you understand that, now very interesting fact. If I talk about an AC supply, which is this, remember that AC supply is the one which changes itself. Take this positive half as a positive. So positive will, I mean, reflect each other, or you can say it won't let positive cycle to pass through. But as soon as the negative comes through, positive and negative attract each other. So negative half will pass, but it won't let positive half pass from the diode. So instead of that, it behaves as a switch. Okay. So one thing is this. So this is anode and this is cathode. So you can say it will only allow, if it's a positive one, it will allow the negative to pass through. So if I draw a waveform along the diode, it will look like this. Why I'm putting this a straight line? Because it won't allow this one. So it will only give you the straight line. It just allow the negative half of that, and it won't allow the positive half, because positive will repel each other. All right. So
Yeah.
now, if you see the graph here, this is interesting. It means that when the positive half is coming to this point, what about positive and positive? What positive will do?
They will repel each other.
They will repel each other. In that way, your diode behaves as an open switch. Open switch means it won't allow electricity to pass through it. It will turn into an open switch. And that type of condition in which it turns into an open switch, we give it a name called reverse biased. So what is the
So,
reverse? Yeah.
so what you've just explained is that the diode has an anode and a cathode.
Yep.
And electrons are negative. So when it's flowing in the backwards reverse direction, uh, it will not conduct
No,
electricity
no, 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 no.
because that.
No, no. I'm not saying in revert or whatever. Listen what I'm saying. For example, now listen to me. Because it is actually normally we place this diode in a AC supply, not in a DC supply. Okay. Now in a AC, I mean in a simple supply of AC, it will be like this, right? Let's assume this as a positive cycle and this as a negative cycle. Same, this as a positive and this as a negative, right? This one is your anode and that one is your cathode. Understood?
Yeah.
Now consider this positive half of the cycle. You tell me when positive half will reach here, positive and positive will attract each other or repel each other.
Repel.
When it repels, you tell me, will this diode allow, because this positive and the positive will repel. So technically speaking, it will actually will not let this positive cycle to pass through the diode. Am I right?
Right.
So when it will not allow positive half of the cycle to pass through, what it turns into? Because there are two situations. One is called as open circuit or open switch, and one is called as closed switch. What I mean is, for example, you put a plug in, sorry, you put a sort of a wire inside a plug in the main supply, but you didn't turn the button on. What will happen? Will your device start working?
No, it will not work.
The simple reason is because you didn't turn on the light or you didn't turn on the button. Am I right?
Right.
But here, it's already turned on, everything is on, even the cycle of the wave, or I mean the electricity comes to the diode, but diode in the situation when positive half reaches to anode, it won't allow it to pass. and it behave as there is no electricity.
So
Understood?
it's an open switch.
So it will, it behaves as an open switch. And this situation, in terms of electronics, we called it that it is connected in reverse biased. So reverse bias condition is a condition in which current do not conduct electricity, or you can say anode receive a positive half of a cycle. So positive will repel each other. So it behaves as a open switch for that particular positive half of the cycle. Or you
Okay.
can say it will not allow the positive half of the cycle to pass through it. This situation or this type of biased, we don't call it biased actually, we call it biased. So this kind of biasness is called as reverse bias. So in reverse bias, no current will be conducted. Understand?
Yes.
Now,
Yes.
as soon as the negative half comes to this cycle, because there is a positive half, then there must be a negative half, right? Now, negative and positive. What is the equation between anode and negative half?
There's an equation.
I mean, equation means what is the situation over here? This negative cycle will be attracted by the anode because anode got a positive charge. I mean, positive
Yes.
electrode. So it will
Yes.
start passing through the diode. So for this particular half of the cycle, it behave as a closed switch. You turn on the button and it start passing. So for positive cycle, it behave as an open switch. For negative half of the cycle, it behave as a closed switch. So basically, your diode is actually stopping one particular half of the cycle, and it actually let the other half of the cycle passing it through. So basically, that type of device is diode. That is what diode is named as a switch. One particular half, it turns into an open switch. One half of a cycle, it turns into a closed switch. Now, in this situation, when it actually let the current pass through, we called it a forward bias. So this is forward biased situation.
Okay.
So when the current, when the positive half reaches to anode and actually no current is passing through the anode, in this situation, we called it reverse biased. Okay. And when when negative half of a cycle reaches to the positive anode, it let the negative half of the cycle to pass through. This situation is called as forward biased. So forward biased and backward biased are two different situations at the same time. So current will behave one half of a cycle. For one half of a cycle, it behaved as a reverse bias, and for one half of the cycle, it behaves as a forward biased. Understand?
Okay. Yes.
Now, if you
Yeah.
see if you see the graph here, this is very interesting. Check it out. Now, if you see the situation here in the first half, I mean in the positive half, you can see that even when the switch is forward biased, it will not just let the current pass through, but it will take some amount of voltage to turn your diode on. What is that voltage? This is 0.6. So initially, it will take 0.6 volt to actually turn itself on. Once it turn on, then it start increasing the current like that.
Is this a general thing like everywhere? If they ask what is the voltage for a diode to activate, is
Absolutely.
it
It is
gonna
general.
be 0.6 volts?
It's 0.
Okay.
It's 0.6 to 0.7. Remember that. In electronics, when I was an engineer, definitely when I used to do calculation, we do calculation on the basis of 0.7. Some books it's written 0.6, some books it's written 0.7, but you can take 0.6 because our Edexcel board and AQA board both are taking it as 0.6. Okay. So it will be like initially it won't. If you see that initially current is not increasing. Why? Because the diode itself not reaching to the turn on voltage. Once it reaches to 0.6, it start conducting. So current increases. While when you go back, if you see the very small amount of current is conducting, the reason is this particular condition is your reverse biased and this condition is your forward biased. Anyone have any question, please ask.
No, this is fine.
No.
Okay, then write it down, please.
Will we go through questions by the end of this session?
These are the questions actually. You know, these characteristics are actually come in your examination. I have seen through few papers in which they have actually shown you the graph and they're asking you what component is that and how does this graph explain what. I think we better finish one complete topic and then I think we better come on the topic which is called the past papers. Let's finish up with one complete
Okay.
module. What do you say?
Okay.
Electricity, along with that, I think we better finish up with waves. So I think it will be a better shape. We will be in that.
Mm.
Because otherwise we have to keep looking at the other topic. So once everything is sorted, things will be easier for us to understand, right? Once you go through it, also read it and tell me if there is any problem while you're writing it or you do not understand anything.
No, I read through it. It's fine.
Alicia,
You
what about
explained
you?
it well.
Good. Alicia, what about you? You will find out this equipment or this component will be LDR, light dependent resistor. Check it out. And we will see what will be the difference. Check it out. What will be the difference? It's on the right hand
It's
side.
negative.
It means that once we increase the current or voltage, instead of increasing, the resistance reduces. Now, this is strange actually, because in this case, the resistance will start reducing. And when resistance will start reducing, that's what actually we do or we actually sees in our circuit. And this actually comes in the form of voltage to us. Now, you tell me one thing. First of all, let's see one thing. V is equal to IR. If resistance increases, voltage increase or reduce?
Increase.
And what about if resistance reduces, voltage reduces? Am I right? It means in the case when the current is constant. Now, if you check this out, you got a resistance in here and this LDR is connected in what circuit is it? Series or parallel?
Is it both?
No, it's series.
Series.
It's a series one because both are connected neck to
Okay.
neck. We will come to that and I will explain you in details. But for the time being, just remember one thing. A series circuit is also called as potential divider.
Oh.
Why it's called potential divider? Because here voltage will be divided into two. One across R and one across this L. Now my point is, listen to me. This R is a constant resistance, fixed resistance. Let's suppose 2 ohms. And let's suppose this is some resistance for the time being at temperature, room temperature, right? My point is initially there, for example, there is a voltage of 2 volts across this initially. Now, as the temperature changes, resistance reduces. If the resistance reduces, voltage reduces as well. Am I right?
Yeah.
And when the voltage reduces, that actually comes as an output which you can use for the change in temperature or whatever.
What do you mean?
Again,
Output for
again. What I'm saying, I may be a bit fast. But my point is, check it out. I'll rub it again. Alicia is joining again, so let's do that once again. This is called potential divider. For example, these two resistance, even LDR and the fixed resistor, this is your 5 volts. Both are the same resistance, so voltage across R and LDR is 2.5 volts and this is 2.5 volts. Both are same initially. Now my point is this is the situation when there is a room temperature.
What does it mean, voltage out?
Output.
As in the voltmeter.
Yeah, you can say voltage out means this voltage can be used for so many purposes. Might be we use that voltage for the purpose of temperature controller. Might be we use that voltage for the purpose of alarm in the factory. Okay. Now
Okay.
check it out. This is happening at the room temperature. Take, take this scenario in a factory, right? Where due to any reason, suddenly the temperature increases, a very badly increases. You tell me if the temperature start rising, what will be the resistance of this LDR?
It will decrease.
It will decrease. And when this resistance will decrease, this value will be reduced as well.
Yes.
And when the value is reduced, you can take this value or you can monitor this value. And on the basis of this value, you start predicting the temperature of that room or temperature of that area. Can you do that?
Yes.
So that is what this light dependent resistance job is. Its resistance will be reduced or reducing, and that reduction in the temperature you can read and you can make your temperature controller or temperature resistor or whatever. So basically, the resistance will reduce as the current increases or voltage increases. So LDR got this VI characteristic graph. This is the ideal condition, and this one is the actual condition. Copy that, please.
Okay.
Also draw this circuit as well. This is very important circuit
Yes.
because this circuit is actually used in so many places. This circuit will be used in the factories as a temperature sensor because as soon as the temperature changed, that temperature can be sensed in the form of voltage output. My question is, what is the difference between light dependent resistor or thermistor?
The difference?
I mean, they are both, they are
A
same or
thermistor gives heat. The purpose is to um give heat.
actually,
Light dependent.
I tell you, as far as VI characteristics are concerned, they both are almost the same. Only difference is thermistor characteristics are like that. If you draw it, it will be like this. A curve,
Oh.
exponential curve. This got the same thing as well. Only difference is thermistor is sort of, it actually works on the heat, while LDR works on the light, and light actually turns into heat. So technically speaking, both are almost same, no difference at all. But you can say thermistor and LDR are, as far as their construction is concerned, they are a bit different. But both got the
Okay.
resistance reduced. Thermistor can be used in a potential divider to produce a device that responds to the temperature variation. It does the same thing. So as the
Hmm.
temperature increases, the resistance of T fall. Okay, that's the difference. It directly works on the temperature while LDR works on the light. That light when actually turns, I mean, hits the LDR, it changes the temperature, or you can say light levels, whatever it changes or whatever it does, it affects your L, or you can say your LDR, and then it reflected back into VI. Okay.
Okay.
So today till now, what have we studied? We studied the VI characteristics of diode, VI characteristic of LDR, VI characteristic of LEMP, and VI characteristic of a simple one. All right.
Okay. Wait, sir, I have a question. These notes you're showing right now, right? Are they available online somewhere?
I don't really know. That's the reason I asked you to write it. But in my videos,
Okay.
if you take it from our coordinator, you will get these notes in the video in the form of video anyway.
Yeah.
Because I tell you whatever lecture I am delivering it to you or whatever notes I have it, they are not from one topic. They are not from one place. They are from multi places. You may not find that pure as it is note from anywhere. It's a mixture of so many notes because this is my work to take the papers and take the things from different places. Then I mix them and then I found a
Oh,
merger which
okay.
is
It makes
actually
sense.
which is actually suited for you. You will find so many things which are
Yeah.
irrelevant to you sometimes. They're not even up to your level or they are even more than that. Till now, everything understood?
Yes.
Good.
Yeah.
Now, once you understand this small concept, now let's come to another small thing which is called as internal resistance. But before internal resistance, let me just explain one thing to you. This is called as Kirchhoff's law. Now, Kirchhoff's first law and Kirchhoff's second law, what exactly it is, and it is just to let you know what actually is Kirchhoff's law. It's not coming in that much details. It will be actually come to. I mean, you will came across this once you reach to the engineering university, but it is in a bit in our course, so I have to let you know. State that the sum of current flowing into a junction must equal the sum of current flowing out of the junction. It can be written using shorthand summation I is equal to 0, and it is fundamentally a statement of conservation of charge. Now, what exactly it is? Let me just show you the diagram here, then you will understand that. Can you see that diagram?
Yeah.
Now, in this diagram, you can see this is your battery, right? This one, E. Now, if you check this out, from here, current I1 is taken out, current I is coming out. Okay. Now,
Hmm.
once your current reaches to this point, how many paths your current have at the moment, at this point?
2.
So your current is technically divided into I1, and then one half of a current is going to this half, so I2. Once this current reaches to this point and I2 current reaches to this point, can I write it that I is equal to I1 plus I2?
Yes.
So that's what
Because we are
your,
the one
yeah.
path.
So that's what the Kirchhoff's rule is saying to you. That current in, that is I, at this point will be equal to current out.
Okay.
And that both should be equivalent. So, in other words, the summation current in is equal to summation current out. They must be equal to each other. This is what we called as law of conservation of charges. Energy will be remain same. The energy going in at one point will be equal to energy getting out on that point. All right. So this is your Kirchhoff's rule. Check it out. Exactly the same. In and out should be equal.
I want to draw that diagram.
Okay, no problem. Destroyed. And label is as I did it. Okay.
Hmm.
So now did you understand why did I give 2 hours lecture on some small quick things related to your O level and everything? Because that was your base at that time. If I directly came to this point, I tell you it would be very difficult for you to understand everything. Now things will be easy for you because your mind is used to take the stuff. So law of conservation of charges. That's the first one. Charges in is equal to charges out. One more important thing, whatever current we are taking here, remember that that current is a conventional current, positive current, not
Okay.
not the negative one. We always do our calculation on the basis of conventional current. All right.
So what does that mean? If we're finding current, it can never be negative?
No, no, that's what I'm saying. To make ourselves 101% clear, we use this as a sign convention because it is being used for quite many years. Even though if it's a negative charge, it won't make any difference except the sign. So sign is not a big problem here. We know that this much is a voltage, this much is a current, so it doesn't make any difference. So we use this sign convention and it's not a problem. Okay. So we just it is, but this is important that we should know that it's not the positive charge that flows, it's the negative charge that flows. Okay.
Okay.
Okay, now the second Kirchhoff's rules. That is very interesting. They say that state the sum of the potential difference across the component in any complete loop around the circuit must equal to the sum of electromotive forces supplied to it. Now, this actually thing is related to the series and the parallel circuit. Can you tell me in this given diagram which circuit is this? I mean, which circuit is where?
Uh, um, but for the circuit of I1, path 1, it's series. Then where R3 is, it's parallel.
Good, good, good. So it means that, can I say that voltage across R3 will be the E? Because it's a parallel, and in a parallel circuit, the voltage remain the same. So can I say that voltage V3, if I give it a name, voltage V3, so V3 is equal to E? Can I say that?
Yeah.
And if I say what is the voltage across each resistor R1 and each resistor R2, so can I say that voltage across R1 plus voltage across R2 will be equal to E? Can I say like this?
Yeah.
So it means that E will be equal to V1 plus V2.
Yeah.
That is what we called Kirchhoff's rules.
Okay.
So sum of the electromotive force applied to it is equal to the voltage across each component in the loop. And this is what we called as conservation of energy. Statement of conservation of energy. All right, understood?
Yeah.
So first
Yeah.
rule, Kirchhoff first rule will be conservation of charges, and the second one is conservation of energy. All right, shall we move?
Hmm.
Okay, now the next small concept, which is we will come to the series and parallel in a like maybe today or not today. We will come to this in a bit. Now, this one is important. This is called internal resistance. This is actually a very interesting topic. What do you think internal resistance is, by the way?
It's the resistance of the cell,
Actually, this is the
the
resistance
battery.
battery itself. Now, what exactly it is? Now, initially, if you remember, I told you one thing when I was explaining you what is voltage, electromotive force, and potential difference. I told you that at some point or another, we call them a same thing, but they are not the same thing. This is a point where I have to explain it to you that they are not the same thing. Now, what exactly it is? If you see a battery inside, you will find out that a battery has two electrodes, one here and one here, and inside battery you will find a liquid. How many of you are taking chemistry? You both?
I
Alicia does.
I take chemistry.
You take chemistry. Do you know there is a word called electroplating?
Yeah, it's where you coat like an object, right, with
Yeah.
metal.
Yeah. So electroplating is same like when electrons are actually coated from one plate to another plate. Technically, this is what the point is. So the thing is, once you start plugging this particular device inside the liquid, electrons start moving from one electrode to another electrode. Am I right?
Mm.
The point is the water or the liquid itself give a resistance to the current or resistance to the flow of or opposes the electron to flow. That resistance is called as internal resistance. So it means that now very interesting fact is we know that V is equal to IR as per the Ohm's law, right? So if
Yeah.
there is a small resistance which is actually shown by the liquid to the flow of electron, can I write it with a small r? Yes, I can. So if I find it out Y is equal to IR, then this will be a voltage which actually lost inside the liquid or inside the battery itself. And this particular thing is called as lost volts. It means that if 3 volt is written on the battery, you may not receive 3 volt 101% at the main terminals. You may find it out as 2.8 or 2.7 volts because zero point 0.3 or zero point 0.2 volts of the voltage will be actually lost within the cell due to internal
Okay.
resistance. You're saying something?
No, I'm just saying, oh.
So, due to internal resistance, when you multiply it by R, you find out lost volts which are inside the battery due to the flow of current through the small resistance, which is called internal resistance. So instead of 3 volt or 4 volt, you will not get 101% the same, but you are getting 2.8 or 2.3 volts. Sorry, 2.7 or 2.8 volts. So you call this due to internal resistance of the battery. So internal resistance is what? A cell itself has some resistance, and this is known as internal resistance. Electron leaving the negative terminal will be involved in collision with the cell itself and will encounter resistance. Some of the energy that the EMF supplied to move charge is used in overcoming the internal resistance rather than in the rest of the circuit itself. So the circuit receive a lower voltage than it do if there was no internal resistor. So basically, so the circuit receive a lower voltage than it do if there was no internal resistance. The voltage in the external circuit is less than the EMF of the battery, and so the current gets bigger, and this effect becomes more pronounced. This is long story written, but actual simple as that is due to internal resistance, voltage actually reduces. If the voltage reduces, what is increasing? Remember that when
Sorry,
voltage,
what? If
yeah,
voltage is reducing, current is increasing.
yes, simple as that. So due to internal resistance, this thing happens, more current start flowing, but this will be more and more pronounced as the temperature got increased and increased and increased. That's what it's written here. So I want you to write the internal resistance thing and draw that diagram. If you see the diagram here, it's shown a battery and a series, it shows a small resistance in the battery. So a battery with the internal resistance is shown in such a way that you will have a battery sign. Along with that, you will shown a small resistance connected in series. Okay.
Okay.
So write it down. Now, Zoha, when is our next class?
Let me check. It will be tomorrow at 7 to 9.
Your 7 to 9, my 8 to 10, right?
It's
Yes.
tomorrow.
Yeah, tomorrow. I mean, your 7 to 9 and mine 8 to 10, I believe.
Yes. Yes.
Today's lecture, anything you missed, let me know.
Um, I know that you haven't showed us the equation for internal resistance.
Oh,
V equals I times little r
no, that's what I
is one
didn't.
equation, but there's
Yeah, yeah, yeah.
EMF equals to I brackets resistance plus
No, no.
small r.
Did you write it? Because it's there.
Yes. Oh yeah, there.
You will get everything, but point is actually I want you to write it. That's why I stopped. Now, if you see this very interesting fact, let me explain this particular thing. Now, this one, this E is the EMF which is written on the battery itself. Let's suppose it's written 3 volt. So I give it a name called 3 volt. What about this IR? And what about this IR? This is small r means lost voltage or lost volts. And this one is something else. This one is simple V is equal to IR. So basically, IR is referred to as the loss volts because it is not available to the rest of the circuit. And IR is called as terminal voltage. So basically, your total EMF will be equal to terminal voltage plus the loss volts. Now, what is loss
So
volts? Loss voltage is the one which actually lost during the what do you call it, cell internal resistance. And what about the terminal voltage? Terminal voltage is the one which actually you got it or you received or you done it on or you found it at the terminal of the battery, which is definitely the reduced one. Okay, when the current start being drawn, remember that when current is not drawn, then IR is not there. It means your terminal voltage will be equal to EMF. All right.
all right.
So I think we stop it here. Tomorrow we will continue from there. And if you have any question related to that, you can ask. Okay. And I will upload this video as well. So if any one of you wants that video or wants to see through this video, you can. Okay.
Okay.
Okay. See you
Okay.
tomorrow then. Bye.
Bye bye.
Bye.
Bye.